A Coca-Cola dispensing machine is set to dispense 8 ounces of cola per cup with a standard deviation of 1.0 ounces. The manufacturer of the machine would like to set the control limit in such a way that for samples of 37.5% of sample means will be greater than the upper control limit, and the 5% of the sample mean will be less than the lower control limit. The question is, at what value should the control limit be set? Well, X bar equals 8, N equals 37, the standard deviation equals 1, the confidence level is 95%, and the sigma is 5, so Z equals 1.65. And in order to find out what value should the control limit be set, you have to add and subtract 8 from your margin of error.
Alright, for B, what is the probability that if the population mean shifts to 1.6, this change will not be detected? To find the answer, you must first find out what the z-score is. So you put in the value, your lower limit for x, which is 7.73, minus 7.6, which is the new mean, divided by standard deviation divided by the square root of n, which is going to come out with 0.79. And if you looked at it in the back of your book, for the z-score for the area, it's going to be 0.2852. So you add 0.5 plus negative 0.2852, which comes out with the area of 0.2148. And when you draw it on a graph, on a chart, where is it? This is the area minus days 2.2148, which is in the reject area. So there's a probability that you will reject it. And for part C, what if it shifts to 8.6, which is actually this area right here, which means you will not reject it. So that's the probability of you not rejecting it would be 0.0222, found out by 0.5 minus 0.4778, which is the area for the z-score of 2.01.